Hello, okay. I guess there are enough people to start. Do you have access to the classroom, or are you all on your laptops?
We are all on our laptops and our phones, yes.
Let's see. But what about, yeah, let me check. What about the classroom?
We asked, but I guess it was too late, so they didn't answer us yet.
Let's see. Okay. So let's start. Okay, this is the link that I will be using today for the notebook. Let me start sharing my screen. So we will pick up from where we stopped last time. We will still be using data on European GDP forecasting. So let me start by importing libraries and making the settings that I need. Then I will go to the folder with my data. Here's the folder again. This is the same folder as before. So I will drop it into the chat again. Okay. So I'm going to load the data, and it will be the same data as last time during the last tutorial, except for the monthly index of consumer prices. I downloaded it from the, so everything is downloaded from the Eurostat, except for the harmonized index of consumer prices, which I downloaded from the European Central Bank, because they provide seasonal and calendar adjusted series. Remember last time when I was using this index as it is, it was not seasonally adjusted, and so it was like too wiggly. And then I use year-on-year change, which is one way to do adjustment, but it's not ideal because all other data set, all other time series seasonally and calendar adjusted, at least seasonally adjusted. While if we want to use the same data time series simultaneously, we need to use the same approach to them, the same seasonal adjustment approach. And also, so there is so-called hard data, which is GDP, industrial production index, and harmonized index of consumer prices. And they are all seasonally and calendar adjusted. Calendar adjusted means that monthly data are adjusted, or monthly or quarterly data are adjusted for the number of holidays in each and working days in each month. Like, for example, in leap years, the number of days in February is less, is 28, it's 29, while in all other years it's 28. And then some weeks have, some years have holidays falling on weekends, then they have more working days and so on. So the Eurostat and the European Central Bank do all these adjustments so that when we look at the long run time series, we are comparing them in a consistent manner. At the same time, there are so-called soft data that I'm using. These are monthly consumer confidence indicator and monthly industrial confidence indicator. They are seasonally adjusted, but not calendar adjusted data. And the reason for this is that it doesn't really matter. So this data sets, they kind of mostly qualitative, not data sets, indicators. They're mostly qualitative indicators. The Eurostat makes survey of consumers or producers in the European Union in different countries in a consistent way, and ask qualitative questions like how you perceive the economy in the past 12 months, in the next 12 months. Are you planning big purchases? How do you feel about inflation? Do you think it will go up, down, or not change? And so they calculate, most of the questions are answered, indexed by -1, +1, or 0. So it's like you expect worse -1, you expect better +1, or you don't expect any change. And then also when they ask about the past, the same idea. And so then somehow they can create it into indicators, and this is called soft data. And the whole reason why the many countries, and this kind of data is also collected in the United States, in Canada, in most developed countries, in Japan. And the reason why central banks and European, statistical agencies collect such data is to see producer and consumer sentiments, and to be able to forecast better what's going to happen. So this is exactly the data that is the primary reason for its collection, is forecasting. So that's why we include these two indicators. We will start using, one thing about these indicators is they can include both questions, summarize the answers from questions both about the past and about the future. And perhaps there is a possible to find the indicators that are only about the past or only about the future. I'm not sure about that, but you should keep in mind that these indicators are both about past and future. And so they perhaps that immediately gives us an idea that perhaps we should use lagged values of these variables for forecasting. And we will not be doing it for some time today, but then eventually later today, we will look at how different models perform when we include lagged variables. Now, and going back to calendar adjustment, it kind of doesn't really matter to do any calendar adjustment to this data because like your sentiment for this month, your sentiment, it doesn't matter if you worked 28 days or 29 days. I mean, not work 20 days or 19 days. So I'm explaining this just to give you an idea what kind of, you should always, when you deal with the data, you should always understand what is in the data. And you should, when you will working with forecasting, you should be, in English, you say you should be comparing apples to apples and not apples to oranges. So I loaded all the data. Now I can, let me see. So then the next thing I'm going to do is to limit my sample. So from the Q4 1995 to Q4 of 2019. As I said last time, I stopped at Q4 2019 because Q1 of 2020, it's January, February, March, the pandemics started and the data was very different. So, and we need, in order to capture that period of the pandemics well, we need to have more years of data. Otherwise, our model will not deal with this period well. Any of the models, most likely, that we consider. Now, here, another thing is that last time I did a mistake. I mismatched the end of quarter and start of quarter. But it, I mean, didn't matter. I was talking about methodology, but today I will be more serious about forecasting. And so I carefully looked at the data and made sure that when I'm matching the different time series, I put them in the corresponding quarters. For example, GDP data is quarterly. What is quarterly here? Is GDP. And okay, this is, let me GDP and industrial production index, they are quarterly. The rest are monthly. And so I will be transferring all the monthly data into quarterly by averaging each quarter over the each monthly values in each quarter, and then assigning the resulting value to the end of the quarter. So for this, if you look at say the GDP, I'm assigning the value, say, of fourth quarter of 1995 to the last day of the quarter, which is December 31st. And the same with industrial production index. And then, like, say, this consumer confidence indicator, it's monthly data. And what I will be doing, I will be, say, for the last quarter of 1995, I will average these values and assign it to December 31st and do it for all quarters. So this, what I'm doing in the next piece of code, this is, I'm just repeating what I've done last time, but I fixed the mismatch of quarter timing that I so last time I had this. I can remove this. So okay, I ran this, and now if you look at say consumer confidence indicator, now it's quarterly averaged and assigned to end of each quarter. And the last thing that I do, the last two things, I convert everything to gross rates. Yeah, at this, by the way, at this point, let me merge the data and plot it. So I merged the data as it is, and then I want to show you the plots, all the series I have. So from the plots, we see that the consumer confidence indicator doesn't look like it has any time trends. Well, this is kind of the whole spirit of this indicator. It's change in this. It's kind of the kind of questions asked in this indicator. They are in the spirit of the change. Like, do you expect it to be better, the same, or worse as the past? And do you expect the future to be better, worse, or the same as the present? So we see that there's no time trends in consumer confidence indicator, in industrial confidence indicator. Then in GDP and index of consumer prices, we see clear trends, and we need to deal with it. And what we will be doing here, we will be working with growth rates of these variables. And then in the industrial production index, it's kind of, we can eyeball and see that it has a positive trend. So we'll also work with the growth rate. So then I go back to the beginning, and I want to convert a bunch of variables into growth rates. But I don't convert consumer confidence indicator, industrial confidence indicator, and everything else I convert to growth rates. And the usual thing in the macroeconomics, when you deal with the GDP, you consider growth rates in logs. So just the change in the variable, like variable next period divided by variable the today -1, that would be percent change, which is calculated by this function. That's called a simple change, and adding back 1 and calculating the log is called the log change. And so we will work with the log change as the customary in the economics of finance, but it can be also, we could have had it like this as well and didn't do this. This is also fine. The reason why we do, when we deal with GDP, we consider logs, because our theory tells us, all the theories of growth that we have, like our economic intuition tells us that GDP is growing exponentially or log linearly. At least it has been like this in the past 100+ years, 150 years. For many countries, GDP was on a linear log trajectory. And on the other hand, in finance, you do logs usually because instead of simple returns, because the models of finance give nice results when you model the data under the assumption of log linear returns. Okay, so enough said. I do this, calculate, then I merge the data, then I plot it again. And so now you see that obviously there is no trend now in GDP. We see there's a huge drop in the European GDP in 2008. That's the global financial crisis. And then 2012, that was the Euro crisis. So makes sense. Then industrial production index seems to be corresponding to this. And then we see that the consumer prices kind of follow also when there was the crisis. The prices fell, then they rebound, so kind of makes sense. Okay, so that's enough about the data. And the next thing we want to talk about is start thinking about to find good models for our data. And I already talked last time about selecting different regressors and using information criteria or out of sample forecasting, out of sample fit to select across the models. This is great. We will use it later. Now we will study a bunch of other ways of finding a good model for our data. So one quick way to see if our model makes sense. So let's start with the biggest model that has all the data. So yeah, let me we will be running GDP on CC, consumer confidence index, industrial confidence, not index, indicator, plus industrial production index plus inflation. So that is going to be our formula. So it's there, and then data is equal there u. Let's call it model benchmark and result benchmark. Model bench fit, and then let's first see at the summary what we get. So consumer confidence indicator is significant, although coefficient is very tiny, but that might be because if we look here, the values are like -5, -10, -20, while the GDP values are like 0, something. We can, I think it's perhaps hard to, well, okay, let's leave it like this. So it's significant. I was just thinking that maybe it makes more sense to multiply the growth rates by 100 to make them a bit more comparable. like percent, then it would be instead of 0.01, it would be 1%, -1%, -2%. We can do this. Perhaps that would look a bit better. Yeah, let's do this. Here, so let's again. Okay, so now the data is in percent for GDP, industrial production index, and harmonized index of consumer prices. Estimate. So now looks a bit. It of course nothing changes in terms of the statistics, but the coefficients look a bit better. So what we see is that inflation is not significant and industrial confidence indicator is not significant, but let's keep them anyway. We will first look at this model, at the full model, and then play around with it, and maybe as we will be changing the specifications, this will become significant, because you would think that inflation matters from just economic logic. But so the good thing is that consumer confidence indicator is significant, which is again why this variable is introduced in the statistics long time ago anyway. And the industrial production index is also known to be a good indicator of what's happening with GDP. Okay, so now one indicator that our model is not the right model is if our residuals have a particular structure. If our model, so this is the big idea or big conceptual point of selecting between models. Looking at residuals can give you an idea if the model is too bad. If you see some structure in the residuals, then perhaps this is not the right model. What kind of structure in residuals we can observe? There are at least two things that can come to mind. Anyone wants to volunteer and say? There are at least two things that should immediately jump at you once you're thinking about structuring the residuals.
Like autocorrelation?
Yeah, serial correlation in residuals, that's one.
They can also be dependent for some reason, but they should
Yeah,
not.
depend. They can be, so they can be serial correlation. Also, they can be dependent on the regressors, which is a bad sign. And this depends. So this is actually, yes, this is the second thing. Either they're serially correlated or they're dependent on regressors, which immediately implies there is heterogeneity and perhaps there is indigeneity. Indigeneity, perhaps it matters more for inference and causal analysis. But of course, if you have correlation, if you have dependence of residuals on regressors, then your model is not capturing everything. You have either omitted variables or something, or heteroscedasticity in errors. So we need to check. So one thing that we can quickly check is if there is heteroscedasticity. Well, you know, even before we do that, we can actually, I forgot, I should have done it. We can plot the residuals. Let me see, I did it in another notebook. So there is a way to, there is a standard function in
Um,
Python.
on our econometrics lessons, we were told that there is a heterogeneity of residuals anyway. Like we should just adjust to it.
Yeah, right. When you're calculating the standard errors, you should be basically calculating the heteroscedasticity robust standard errors, like using white standard error. So there are other ones. So you do it by, when you do the fit, you do uh, what's it? HS0 robust, something like, I forgot. But this is yeah. One second. 1, just give me 1 second. I will pull out another notebook. I don't always remember all the standard comments. I'm switching too much between different languages. I program a lot in C++, sometimes in R, sometimes in MATLAB, and I keep forgetting where is what. So this one is I will use wide standard errors. And now about going back to this issue that you should just by default use heteroscedasticity robust standard errors. This is of course true, but if your errors are too wild, or like you see some dependence of errors on data, then on something, or you see serial correlation or some wild heteroscedasticity, then that just indicates that your model might not be right. And one like classic way of thinking about it is that when you work with time series, you should decide, should you work with the growth rates or you should work with levels, and or you should, sorry, with the log or with just levels. Suppose your time series are stationary, so you don't have time trends, but then you still might be willing to convert everything to logs. And one way to see this is that if in levels you have heteroskedasticity, but in logs you don't have heteroskedasticity, then perhaps the log model is the right model. I mean, you should also use some economic intuition to decide, but this is also another way to take a look at your residuals. So let's see. Let me see if this works. Would it work? No? Nope. I have no idea what this exogenous index. I see. Let's say so this is just, I guess, the standard function to look at compare your residuals versus inflation. So, for example, this graph is what I was looking for, the top right one, and we don't see any particular structure, which is great. We can do standard test for this, which I was wanted to do. So let's say do the one standard test for this, which you know from the econometrics, is Breusch-Pagan-Godfrey test. So the residuals res main model exogenous. And say, oops. So if we run this, it would give us 4 values, and 2 of them, sorry, keep jumping. 2 of them are low, LM maximum likelihood test. Oh, sorry, maximum Lagrange multiplier test and p-value. This is the first two, and then the F statistic. So LM statistics, LM p-value, F statistics, F p-value. So then we can do this. Series. just write it in a nice way. And so here the point is that the in all this heteroskedasticity tests, you can always check the documentation for this function. For all of them, the H0 hypothesis, the null hypothesis, is that there is how you say it, heteroskedasticity, homoskedasticity. And the alternative hypothesis is that there is heteroskedasticity. And so the p-value is very large, so we cannot reject H0. With high probability, H0 is right. And these tests, we look both at Lagrange multiplier test and F-test. They're a bit different, and you can, I'm pretty sure you learned this in econometrics, like say this test would be, I guess, the most important test for you. In other situation, you basically look at both tests, but here they give you the same p-value, so it doesn't matter. And of course, an alternative is to do the White test.
So in our case, our residuals are homoskedastic, right?
Homoskedastic, yeah. So which is good, which it doesn't jump at us that the model is still wrong. And again, in econometrics, your focus is the correct inference. For us, we're using this as a tool to check if the model makes sense. And heteroskedasticity of errors is an indicator that perhaps the model is not the right model, is one of the indicators. So keep in mind this distinction. And the same way here, when we are looking at significance of these coefficients here, we care about the significance as long as the model is to select the right model. So if the coefficient is insignificant, then maybe we shouldn't include it into the model, because we might be overfitting the data, and I will talk about overfitting in the coming tutorials or lectures, and overfitting is bad. But let me go back to this. So I'm doing now the White test. It has the same structure and just a different way of checking the checking the heteroskedasticity. The White test, I think, it runs the regression of the residuals on all the independent variables. And so we see that, again, the p-values are quite high. So we conclude that errors are homoskedastic, so our model passes this simple test. The next thing that we want to look at is serial correlation and in residuals. And of course, we already saw here that, no, we didn't see it here because this is just a regression of residuals on inflation, but we can say, let me see. So we can do there you and here. Okay, so we plot residuals over time, and how would serial correlation look like? Serial correlation would look like that there would be like ups and down in the variables. Like it would be like smoother and going with some shocks up, then down, something like this. While here we see that there is no particular structure. They're just, the residuals are very wild, like they're fluctuating. So just eyeballing it tells us that they don't seem to have this time structure, but we can have a formal test for this. And the formal test is Darwin-Watson. It literally runs a regression of it's one test of first order serial correlation. It literally runs a regression of residuals on the lagged residuals and test if the coefficient is 0 or not. So it's, of course, we can do it manually. But we can also do it like so. No? So now, usually for, you can go to the Darwin-Watson. Here, I think it says somewhere. So the statistic is always between 0 and 4. No serial correlation, the statistic would equal 2. And if it deviates too much from 2, then like closer it to 0 from 2, the more evidence of positive serial correlation, the closer to 4, the more evidence for negative serial correlation. And like ours is closer to 2. Usually the rule of thumb is it should be I think they write it. Do they write it what it has, what distribution it has? I guess Darwin-Watson distribution. So is that within, then there is no relation. So we kind of on the edge, but perhaps there is no serial correlation. We conclude that there is no serial correlation. And also there is a Breusch-Godfrey test, which test higher order serial correlation. No first order serial correlation. And then test BG. That's diagnostic. Res benchmark, and then we need number of legs here. So say number of legs is 2. So we test second order serial correlation. And I think it has well, not I think, I know it has the returns Lagrange multiplier test statistic, p-value, f-value, so the same as Brioche got free test for the homogeneity, homoscedasticity, sorry. So and so the second order, it kind of relatively high, so we reject. Well, we can look at the third order, yes. So, but the first order is kind of on the edge, the same way as this one was on the edge. So it might be, it might not be, but just from our economic intuition, perhaps there should be serial correlation, because we would expect that lagged values of these variables matter for GDP, and that would create serial correlation. So we will talk about it later today. So we are, again, the conclusion is that we are on the edge. We'll continue for now with the model without lagged variables, but we keep in mind that there is some indication of serial correlation. Now, the last thing that we would check would be normality of the residuals. And normality of the residuals is not needed for any of the inference results, but usually if residuals are not normal, again, this might be an indication that we should use some different model. Like sometimes if maybe we should do some transformation of the model, because normal residuals are nice. If residuals are normal, then all kinds of tests work, because most of the tests are working for normal residuals or normally distributed data, and then especially in this linear regression context. And they asymptotically work for non-normal residuals as well, but their results are asymptotic. And it also, if we see some wild distribution that doesn't make any sense, then wild distribution of the residuals, then perhaps we should change the model so that the distribution of residuals looks closer to normal. And one way is there are formal tests. And again, as before, we will first look at the graph. Residuals plot, histogram. So it does, so let me read, say bins. Let's add more bins. Okay. And let me hard to say, but doesn't look that bad. But we should do formal tests for it. Just made the widths of the bars a bit smaller. So doesn't look that bad. there are not massive outliers, which is great. So we're also looking for massive outliers. If there are massive outliers, then maybe our model is not the right model for this data. Now, one test that is actually routinely reported is Jog-Boero test. Jog-Boero test is this one, and we already have it here. So the p-value is 0.48, which is the H0, again, the null hypothesis is the normality. And the probability is quite high, so we don't reject this hypothesis. So the one test tells us that we can probably the data is normal. And then there are other ways to do it. There is in statistics, it's not usually taught in econometrics, but in statistics, there is also so-called QQ plot. Statisticians like it. I skip it, but you can look at it. I used to draw it in the past, but I think it's fine. So you just eyeball, seems not so wild. Because eventually, when you will be thinking about forecasting, when you're working with the real data and you're trying to forecast, you will be experimenting with many models. And most likely you will not have the time to look at all the graphs, you would be doing probably perhaps automatically some tests, some statistical tests. So anyway, test Jog-Boero test is results. So this is the test itself, this is the p-value, and the other two values are skewness and kurtosis of the data. So this is 0.486 is this value. We can okay, so we did the basic analysis of the data, and it looks like the model is not so bad for now. Of course, the ultimate test is how well it forecasts, how well it performs with forecasting, and we are getting there. But we are kind of examining the model from different aspects of the model. The next thing, a very important thing, is parameter stability. And what we are going to do there, we are going to check if with time there is a change in the model. Sorry, not in the model, but in the dependence. So the model can stay the same, just a linear dependence, but the parameter values can drastically change with time, potentially. And like for example, GDP was responding to inflation 1-to-1 up to a certain point, and then maybe after some other point, it started responding 1/2 to 1. 1% rise in inflation was increasing GDP to 1.5, like 1.01, like 1% higher. So for this, one thing is to do is so-called Chow test, and we are going to look at this Chow test first, and I'm going to implement it. So the Chow test, let me write it. This. And that test, its null hypothesis is we divide the sample into 2 periods, and we test if in the 2 periods there is so we estimate the same model for 2 periods before the breakpoint and after the breakpoint, and we test if the coefficients are the same and the variance of the residuals, the variance of the error is the same before and after, against the alternative of being not the same. So
Excuse me.
this step, yes?
How do we know the breakpoint? Is it like
Yes, right. The breakpoint, somehow you need to think about it. And for us, let's go here. One way to decide is to just eyeball the data and say, like we see here, it doesn't seem to be that different GDP. And then there is this drop, and then there is this global financial crisis, then there is the euro crisis. So perhaps we should take before Q1 of 2008 and after Q1 of 2008. So let's say, not sorry, Q1, the collapse of the Lehman Brothers, which was September 2008. So we would take second quarter and after the second quarter of 2008. So that's one way, just eyeball and decide from your economic intuition. I mean, subject area. And by the way, just let me stop here and make some important point. Do you know about AlphaGo? Have you heard about AlphaGo?
not really?
Not really. Okay, so in your free time, this is a fascinating I think this is the one. Watch this documentary. This is a fascinating documentary about how this company, DeepMind, which now is a part of it's a British company which is now a part of Google, but it was an independent company. A few years ago, they won against the world champion in the game of Go. So the game of Go is a Chinese game, and at the time, the world champion in this game was in Korea. And this is considered to be a super hard game for a computer to play. And before this AlphaGo, before the company DeepMind, there was no no computer couldn't defeat the best players. And then this company, they started playing against regional players in Europe. Specifically, they played against, the computer played against this guy who was the champion, a Chinese guy who was the champion of Europe or France, I forgot. And it won. And then they hired that guy to help them to make this game better. I mean, make the computer better in playing. And then they, together with this guy and a team of engineers, they played against the world champion at the time, a Korean guy, and they won like 5-1. The guy won one time and the computer won 5 times. And why I'm telling you this? The key to what we are discussing here, the key here is that they needed to hire that specialist, the European champion in this game, who helped them to make a better computer program. The guy has no idea about programming, but he is obviously an expert in the game. And they needed that expert to help them to make the program better. And this is something common in how lots of progress is made in artificial intelligence. Another example, a few years ago, maybe 3 or 4 years ago, no, not 3 or 4 years ago, let's say 6 years ago, 7 years ago, was the first big breakthrough in natural language processing when Google Translate was released. At first it wasn't so good, but then I think it happened about 7 years ago. Definitely when I came to Japan, it was already amazing. I was just surviving here. I came here knowing 0 language, and I was just using Google Translate everywhere, and it was amazing. I would go to a shop, I would scan, and I would read all the labels, and then I would use it to speak. And it was a huge breakthrough. And then there was another breakthrough a few years later, and they achieved another level of quality of translation. And the point is that they used linguists to help them. So it's not like computer scientists who have no idea about linguistics came up with some smart programs that help them to make breakthroughs. It were breakthroughs in linguistics and computations. The same, like they needed in the play of Go, they needed specialists in Go to make those breakthroughs. So now going back to economics, you need to know economics, and you need to know what's happening in the world to guide your models and to be better at forecasting. So hopefully that gives you like motivation that you cannot just take without thinking all the statistical tools and programming and then come up with good forecasting. Usually it's not enough. Okay, and so that was long but very important diversion. I think this is, I like making this diversion because for me it's just kind of shapes your thinking about how you should be thinking about forecasting prediction in the right way. That you cannot just go with statistical tests. You definitely need to have a good understanding of the subject area. And so we know that something bad was happening after this. And by the way, the years before 2008, the several decades before the 2008, we know in macro, they're called the Great Moderation. And so when the economies were stable, inflation was, it's like 80s, 90s, and 2000s. And then after the global financial crisis, it looks like the economy started getting haywire. We don't know why. Like there's the Lehman crisis, the global financial crisis, there is the European crisis, Euro crisis, then there is the pandemics. Maybe those are just unlucky shocks. But anyway, there is a reason to believe that before 2008 and after 2008, these are different epochs. Okay, so talking too much, let's go back to the quotes. And I think we're supposed to have a break here, right?
Yes.
Okay, let's, I guess, do it for like, what is, where is my schedule? Okay, so it's 4:50. Let's do it till 11, 4:50 my time. Let's do it till 11:10 and then reconvene in 15 minutes.
Okay.